Section 1.2 Limits of Functions. There are situations when direct substitution will not work. If that is the case, we will need the following theorem in order to evaluate limits. Functions that agree at all but one point. Let c be a real number and let f of x equals g of x for all x not equal c in an open interval containing c. If the limit of g of x as x approaches c exists, then the limit of f of x also exists and both limits agree. What it means is we can do algebraic transformation of some functions. Then we will be able to evaluate the functions on the new expression. Let's take a look at example number 2. We want to evaluate the following limits. So part A, when we do direct substitution for x cubed minus 1 divided by x minus 1, we realize the numerator or the denominator and the numerator are both 0. Well, we cannot have a 0 denominator, so direct substitution will not work. So instead, we want to use the theorem above and transform the fraction into something else. And the first technique we want to think about is factoring. So because we're transforming, we still need to write a limit sign because we haven't evaluated yet. We want to factor x cubed minus 1 because x cubed minus 1 is the same as x cubed minus 1 cubed. So we want to have difference of cube formula. It will factor as x minus 1, x squared plus x plus 1. If you're not familiar with this, I suggest you to review factoring for college algebra. In the bottom is x minus 1. Now we are able to see we have x minus 1 on the top and x minus 1 in the bottom, so we'll be able to cancel this factor. So once cancelled, we see we have x squared plus x plus 1 remaining, and that expression is equivalent to x cubed minus 1 divided by x minus 1, except at x equals 1. Well, then we can apply the theorem above and evaluate using direct substitution. So direct substitution is always a way to do the evaluation unless we encounter a 0 denominator. So in this case, we substitute x equals 1. We get the limit equals 3. Now for part B, same situation. Actually, it should be x approaches 5. Okay? Because if it's just x approach 0, we can just plug in 0. So here, x approach 5. And direct substitution give us 0 denominator, so we have to do something else. Now some of you might be able to do factoring, but if you're not sure, well, we see radical expression, so we want to think about conjugate. So what is conjugate? What is a conjugate of square root of x minus square root of 5? Well, it is the same thing. Okay, so you will multiply top and bottom by the conjugate. And the conjugate of the radical expression is the same thing, square root of x, square root of 5, except it will be a plus sign. Okay, the sign will be different. So we multiply square root of x plus square root of 5 for the top and bottom. Now for the top, with the conjugate, we see it's like a minus b times a plus b. So it's the difference of square formula. We will get a squared, which is square root of x squared, so you get x, and b squared, which is square root of 5 squared, is 5, and it's a negative sign. Okay, so x minus 5 on the top. In the bottom, you do not FOIL it because we want to be able to do a cancellation. So we see x minus 5 and x minus 5 in the top and bottom. We want to cancel it because x minus 5 in the bottom is the trouble that we have. Now we can plug in x equals 5, so we get square root of 5 plus square root of 5. On the top is a 1 because when we do a cancellation, we get 1. On the top is like 1 times x minus 5. So the final answer is 1 over twice square root of 5, or you want to rationalize the denominator, so you multiply top and bottom by square root of 5, so it's root 5 over 10. For the last one, same problem. When you plug in x equals 0, you have a 0 denominator, and because we have a radical expression, we want to multiply by the conjugate. So it's square root of x plus 1, and the 1 has to stay the same. Okay, you don't change this plus sign to negative because you want, what you really need to change is the sign connecting the radicand and the constant. So you change the negative sign to a positive sign. So in the bottom you multiply by the same thing. Then we get limit as x goes to 0. On the top, we get x plus 1, square root of x plus 1 squared. So we get x plus 1. And then it's the next subtract sign. B squared, which is 1, so it's just 1. And then the bottom is x times square root of x plus 1 plus 1. Now we simplify the top. It will be x on the top and x in the bottom. They should be able to cancel, but I just want to make sure you understand the x on the top is the same as x times 1. So now you cancel the x. And you will get 1 in the top. The bottom, direct substitution, 0 plus 1, square root, and then plus 1. So it's just 1 over 2.